This is your civil pro Mainak, and today we are going to discuss about bar bending schedule of beams. So basically we are going to discuss how to calculate the stirrup lengths of beams. So we know the stirrups are of different types, and we are going to cover most of the types and most of the shapes so that you have an idea of how to calculate the lengths of these stirrups. So this is a normal rectangular column which you often find inside. There can be different types of stirrups here. As you can see, the number one stirrup is your rectangular in shape, and it can also be of this shape, like this diamond shaped, and sometimes it can be of this shape as well. Suppose this is a column here or a beam section, and we have here four main bars. So this is the common ring number one, and you can have another two rebars here which will be joined by another hook. So this is number two. So like this there can be different types of stirrups. So we are going to exactly discuss how to calculate the lengths of each. It's very simple. Just once you go through this entire video, you'll be able to understand the entire process. Okay, so let's get started. So first of all, we'll take a normal, very basic thing. This is a column or a beam section. So the size of this particular section, let it be 600, and let this be your 600 as well. Okay, so this is the first example, and we have four main rebars. Okay, four main rebars we are having here, and we have this stirrup. So now in this stirrup, this is the hook portion, this one, and the other portion is also there. So let's calculate the length. So for calculating the length, first of all you're going to know what is the diameter. So dia of stirrup, let it be your 8 mm. Okay, dia of stirrup you have to know, and cover or clear cover. So clear cover, that is the distance between the end of the concrete surface to the your reinforcement. So you have to know that. So let the clear cover be 40 mm. As in case of columns, it is 40 mm. Some beams also it's 30 to 40 mm. So it is mentioned usually in the notes of the drawing. So you have to check what is the clear cover, and you have to check what is the dia of stirrup. So once you know that, so the dia of stirrup in this case is 8 mm, and the clear cover is 40 mm. So how to calculate this stirrup length? So its basics is pretty easy. So I'll write length equals to, so 600 and 600 minus 80. So if you do 600 minus 80, it will come out to be your 520. So why 600 minus 80? 40 from this side and 40 from this side. I'm starting from this. Let it be my 1. Okay, let it be 1. So this will be your 520. So now if I had different lengths here, then I would have to calculate that would be 520 into 2, and then it will be different for different things. But now the length will be 1 2 3 4. So 1 plus 2 plus 3 plus 4 will be 520 into your 4. Okay, so this is the length, and then plus it will be your these two lengths of these two hooks. So now these two hooks, you have to study the drawing what is written. So generally what is the length is for this hooks is taken is 10d or 75 mm. So you can take 75 mm as for one particular hook, or you can take 10d. So if you take 10d here, it will be your 10 into d, at what the diameter of the stirrup in mm, which will be 80 mm. Okay, or if you take 75 mm, then we can take 75 mm. So please look into the drawing what is written. So you can take either of these. So let's go with 10d. Okay, so here it will be 80 into 2. The entire calculation we are doing in mm. So it will be 80 into 2. Here we are taking the 80 mm. Okay, so this 1 to 3 is covered, and then the two hooks are also covered. Now comes the deduction. So for the deduction, you have to know a particular theory. For every 90-degree band, there has to be a deduction of your 2d, where d is the dia of bar in mm, and for every 135 degree bend you have to do a deduction of 3d, where d is the diameter of the bar. So here in this particular figure, if you just expand it, I'll just draw it again. You have to know how many 90-degree bends and how many 135-degree bends are there. So these are the 4 rebars here, and these bends which I am just writing in blue, 1, 2 and 3, these 3 bends are, this blue represents the 90-degree bend. And for this particular hooks, these 2 hooks, as per the IS code, these are bent at a 135-degree angle. So these hooks, these are 135-degree bent, and these are the 2 bends. So basically if you see at sight also, you'll know that this particular hook, if we expand it, it looks like this. So this will go here, and this particular hook comes like this, and this is bent like this. It is kind of like this. This is one single bar, it is bent like this. So now we have 2 number of, that is 135-degree bend. So this 90-degree bend is your 3 numbers, and 135-degree bend is your 2 numbers, that is 1 and 2. Okay, so I hope it's clear. So now if we go back here to the calculation, there will be deduction for your this, that is the bends. So let's deduct here for the 90-degree bends first. So it will be 2 into d. So it is d is 8 mm. So it will be 2 into 8 for the 90-degree bend. What is the number of bends? Number of bends is 3. So it will be 3. And for this 135-degree bends, it will be your 3d, that is 3 into 8, and the number of bends are 2. So if we just calculate this, then we'll have this 2240 minus 96, that is 2144 mm, or you can write here this is 2.144 meter. So for making one particular ring, as they call inside, and we call stirrups for in the case of beams and ties in case of columns. So for making one particular stirrup or tie, you will need 2.144 meter for a column or a beam size of 600 mm. So now let's see if you have understood this basic thing, you can practice it. And now we'll go a little one step further for your different type of rebar. So let's give here, suppose we have a column. So this is let's give this as problem number 1. This is the most simplest one. So now I'll give here problem number 2 here. So here we'll have different column sizes. Suppose this is your 600 and this is your 400. Okay, and we have a bar here like this, and there are 4 main rebars, and there are 2 like this, there is the hooks. So there are 2 actually kind of rebars here. So this is stirrup number 1, and if you have this stirrup number 2, this is the stirrup number 2, or in the form of hooks. Okay, so now we have to calculate the length of 1 and 2. Okay, so let's calculate it. So if you want, you can do it yourself, just practice it, pause the video, practice it, and then see what is the answer. Okay, let's continue. So now for 1, let's calculate the length. So it will be your the dia of stirrup is 8 mm here, and the cover is still 40 mm. Okay, so these data are the same. Now let's calculate. Okay, So it will be 600. So this is 40 and this is 40. Okay, 600 minus 40 into 2, that is 80. Okay, 40 into 2 or 80. Now this will be into 2. Okay, this is 1 and this is 2 into 2. So, and plus similarly this side is 400. So 400 minus 40 into 2 or 80, you can write directly, into 2. Okay, this is the main things and the deductions. So the deductions will be minus, there are three number of bends here, 90-degree bends, 1, 2 and 3. So similarly there will be 3 number of bends into 2d. So 2 into 8, and there are two number of bends of 135-degree, that is for the two hooks here, 1 and 2. So it will be 2 into 3d. So now after the deduction, there also will be addition for your hooks here, that is the two hooks. As you can see, these two hooks, there will be addition for that also. So plus that will be we are taking 10d, so it will be 80 into 2. So if you calculate the total length, it will be your 1744 mm, or it will be equals to your 1.744 meter. So this will be the total length. So now let's calculate for the stirrup 2 here. For the stirrup 2, it is along the side of your 400 mm. So the length will be equals to, so it is like this. So there is a top cover here for the stirrup, and there is a bottom cover as well, basically these two sides. So the length will be your 400 minus your 2 into 40, that is 400 minus 80. This will be the length, and we also have to just do the remaining part. This is the basic one, and let's add for the hooks. So it will be plus 10d, that is your 80 into 2. So why 2? So because we have two parts here, 1 and 2 for the two hooks, and then there will be your deduction. So now as you can see, this bend is a 90-degree bend. Okay, so one bend and two bend. So there are two number of 90-degree bends here. So it will be your 2 into 2d, that is 2 into 8. Okay, so if you just calculate the total quantity here, so it will be 448 mm or 0.448 meter. So this is the length if in the case of this stirrup in the shape of these hooks. So now let's go to our last work problem, that is work problem number 3, and here we are going to have the diamond type. So diamond type stirrups here we'll have. So let's have this 600 into 600 beam, and we'll have stirrups of the diamond type. So already we have calculated the basic things will be remain the same, that is your 8 mm will be the stirrup dia, and your 40 mm will be the cover. So these things will remain the same, and since we have already calculated for stirrup number 1, we'll calculate for your 2 or the diamond one. Okay, so let's calculate. So for this the bends, let's see what are the bends here first. So the bends here, you can see here for the bends we have this your two number of bends here. So if you look at the bends, there are actually three number of 90-degree bends. If I just zoom the picture here like this, so actually all these are 1, 2 and 3, these are the 90-degree bends. Okay, so we have the three number of 90-degree bends here. So when it comes here, so one portion like goes like this, another portion goes like this. So here we have two numbers of 135-degree bend. So we have two numbers of 135-degree bend here, and we have three numbers of 90-degree bend, and the remaining portion, that is the main bar length, that is you find A, B, C and D. Basically these are calculated by the Pythagoras theorem, that is the hypotenuse equals to that particular Pythagoras theorem we'll use here for calculating this. So for let's calculate here for your B. So basically this won't be A B C D, since all are the the same, the column is of the same length, so it will be A's only. If it was of different lengths, then it would be a little bit different here. So it will be your, this will also be A, this will also be A, and this will also be A. So if it were different lengths here, then it would be A and BB. Okay, so let's do it first. So this particular length here, if you just calculate that, I'll just zoom in this section here. So this is like this, this is like this. Okay, so here this portion will, the length of, but this particular portion will be your, if this is 600 and this is 600 minus the cover from two sides, that 40 40 80, so this will be 520, and this will be here 520 by 2. Okay, so this will basically be here 260. So this particular length will be here 260, and similarly this length is also will be your 260. So this is the perpendicular portion here, and so now we have to calculate this, so which is A. So we know by the Pythagoras theorem, hypotenuse square will equals to be base square plus altitude square. So this A will be, you have to use this formula, A will be your root over of 260 square plus this 260 square. So if you just calculate this, it will come 367.7. so the length of the stirrup will be your, length will be your 4 into 367.7. this will be the length here, that is 4 A's, and it will be plus the hook lengths here. There are usually two hooks here, so it will be 2 into 10D, that is 8 mm. And now the deductions, minus how many bends we had discussed, there are three number of 90-degree bends here, and minus 3 into, for 90 degree we deduct 2D, so it will be 2 into 8. So this is for these three number of bends and two number of 135-degree bends, 2 into 3 into D, that is your 8. So if you calculate this, it will come as 1534.8 mm. So this will be the length here. And for the same problem, if you just make this as, let's say you make this as 400, okay, so then let's make this as A, and this, let's make this as B. So A length we already know, and B is 1. Okay, A length will also change here, so the problem will change. So this particular length will then remain the same, that is your 520 by 2, that is your 260. This will remain the same, and this particular will be 400 minus 80, that is 320. 320 by 2, that is 160. So this will be 160. So A will be your root over 260 square plus 160 square, and here this particular value will be, if you calculate this, 260 square, root over 260 square plus 160 square, and it will come as 305.29. It will be 305.29, and b will be your root over here. So for b will be this one and this one, so it will also be the same, that is root over 260 square plus 160 square equals to 305.29. okay, so now it will be 4 into, this value will change, it will be 305.29, and this 2 into 10 into 8, that is, this is for the hook lengths, it will remain the same, and the directions will also remain the same. And if you calculate the result, it will be your 1285.16 mm. So this will be the result for this triangular hooks. So now I know the video length is large, but let's finish everything. Now let's calculate for the circular ones. So suppose you have a circular column or circular beam. Let's calculate the, so you'll have this, for a circular one you'll have minimum 6 number of your main rebars. So suppose you have different kinds of arrangements are there here. Suppose you have here one rebar here like this. Okay, so how to calculate this length? And we have this dia of is 300 mm of the column. Dia of column is 300 mm, and that is this one is 300 mm, and stirrup, or if you, this is column or there will be tie. Let's like link, it is goes with both. Link dia, that is the tie or stirrup dia, is your 8 mm, and the cover is also 40 mm. So now if you calculate the length of this stirrup, let's give this stirrup name as 1. So first of all, it's very simple how to calculate this. So this length is 300 mm, and if you look into the inside, this particular length, maximum length or the dia, you have to calculate. So this length will be 300 minus the cover, that is 40 into 2, that is 80. So this will be your 220 mm. So this 220 mm will be this dia of this particular link. So now if you calculate the link length, you can calculate using the simple formula of circumference of a circle. So it is it will be equals to 2 pi r, or also it can be pi d. Okay, 2r equals to d, so it will be pi d. So length of tie here, it will be pi into your d, which is the diameter here. So it is 220 mm, 220, and what will the additions here? That is for the two hooks, 2 into your 8 mm, or hooks are there, so 10d, so 8 into 10. And let's go for the deductions here. So since there are no bends here, as you can see, only two bends are there, that is 135 degree bends will be there. So 2 into your, for the 135 degree bend, 3d, 3 into your d, that is 8. So if you just calculate this, you'll find, so if you take the value of pi as 3.14, 2 places of decimal, and calculate this, you will find the total length as 802.8 mm will be the length of this circular rebar. So if you have watched this video till now and you have practiced all the 4 examples, so friends, if you found this video useful, do hit the like button. It helps to reach more people, and you can also follow me on LinkedIn. I have given the link of my profile in the description. Bye bye.